When we generally talk about functions, we always pretty much give you perfect functions to kind of study them. Now we're going to talk about real world applications, and things aren't always perfect, and there might be things that are just a little bit off, and we'll talk about that. But generally speaking, looking at this first question A here, what do you see those dots are doing? Yeah. They're creating a positive line. And I could take and I could kind of draw a line. This is called the line of best fit. And I should use a straight edge, but I don't have one. But it's basically a line that's close to all the points. Okay. When it asks what's the association, we say it's linear because it's a line and that it's positive. So when they do studies, and they say, hey, we found some results. As people do this, this happens. They expect to see something like this. If I do a study and I say, hey, look, I got some results on this one, what would you say is true about that one? Say again? Yeah. It has no association. So sometimes they study things and they realize, maybe there's association, maybe there's not, right? Sometimes it's super obvious that there be association. I study more, I get a better grade. I do all my homework, I get a better grade on my test. Okay, I have been able to find that my getting your homework done and your test scores dramatically are or closely associated. Okay, so something that would not be associated would be like the temperature outside and your score on your test, right? And you might go, well, actually, we found that there was a result, right? If it's super nice outside, kids don't study as much. But I don't know. Maybe we'd have to test that. Okay. Let's see. How can the relationship between the hours after sunset and the temperature be modeled? If the relationship is modeled with a linear function, describe the correlation between the two data sets. What happens when the sun goes down in relation to the temperature? The temperature goes down as well, right? So it's not perfectly linear, right? And eventually, but it's pretty close, right? I can kind of make a straight edge here and kind of say that's generally what's happening. If it's the summertime, it only gets to a certain temperature and it kind of will level off, right? It doesn't. And then what also happens after so many hours of the sun going down? It comes back up, and then what does that do? Yeah, it's gonna be like a V. Remember that one function I showed you, the sine where it goes up and down? Okay, it's kind of more like that if we talk about days. But if we're just talking about this, then that's our association. What kind of association does this have? Yeah, it's a negative. It's linear, and it's negative. I can't spell today. Negative. Okay. So a negative association means as the time goes up, the other thing goes down. Positive means as one goes up, the other one goes up. So a lot of times what we need to do is we need to make a model. Do me a favor and circle this word. I'm not sure why, and I get that it's confusing maybe, but what is a model in algebra class? Because a lot of times people come up to me during a test and go, what does it mean by model? Not a graph. It's an equation. So it's a y equals something. So it's an equation. And that scares me a little bit because when you get a state test and it says, give me a model, luckily most of them are multiple choice. So you're like, oh, I see what it's saying. But that just means write me an equation. I want to know what y equals is. I like to use this technique called the first and last point. Okay, because we're kind of giving an estimate here, right? And really, when I draw my line, I'm going to go ahead and use the first and last. If I don't use the first and last, and someone draws a line, how many different lines could we make here that could be close? Say again. A lot, right? So I might be a little bit closer to this point and you're further away. So I like to use this concept of first and last point. So I ignore all the points in between. I only use the first and the last. So I need to know the first ordered pair. I need to know the last ordered pair. What is that first ordered pair? And again, we're not perfection here. We're kind of getting things close. What does that look like that roughly is? Yeah. Like 30 or like 30? Okay. And what's the first point? Like 2. 2? This would be 2. Yeah, I like it. I like 3 better. 3? See, and that's where on this one we might get slightly different answers. And I have to kind of accept a range of answers. If you told me that ordered pair was 550, you're losing points. Okay. What's
1? How would you get 3? 1 or 2? 3 would be above.
Because this right here is 2.5. Definitely 3 wouldn't work.
I say 1. I think it's 2. 1.5. It's 2.5. It's 1.5.
It's not 2.5.
1.5. It's 1.
Again, I would accept a range. Somebody tell me what that other ordered pair is.
Is that not half lived? It's 2. It doesn't matter. He said he's accepting a range.
Someone on this side, yeah. Say again. This one here. So we use the first point. It's okay. We use the first point and we use the last point. I think it's more than 16. Can we do 17? Is that okay? And then what was the other one? 250 is pretty clear. So if I have those ordered pairs, and would you agree that this is pretty close? Okay. What we wouldn't want to do is do first and last if we have what's called an outlier. An outlier just means a weird thing that happened. Okay. So we can now write our equation. How do I write a linear equation? What 2 things do I need to know? Yeah, so I'm going to go up here and I'm going to give myself some space to make the slope. Change of y, so 250 minus 30 divided by 17 divided by 2, or 17 minus 2. So that's 220 over 15.
That's
14.6 repeating.
I told you, bro.
So there's my slope. So I'm going to go over here and I'm going to write 14.6 repeating x. How do I find my y-intercept? Now, I don't want to just eyeball this because I've kind of decided these are my ordered pairs. Yeah? Plug in one of these points. So which one do you like to plug in? 230. I agree. I like that 230. So then I'm going to come over here and I'm going to go 30 equals 14.6 repeating times 2 plus b. Anytime you don't know one of the points, you can, or one of the parts of the equation, you plug in a point. 14.6 repeating times 2, and then 30 minus that. And this is going to be kind of a weird answer, but this is what we get based on our ordered pairs. Which one? Yeah, but you can copy, right? Okay. So then 0.6 repeating is my B, so this is plus 0.6 repeating. So there's my equation based on my first and last point. A lot of times, they'll ask you to make a prediction based on this, and then I can just plug in values, right? So what if it's so many other degrees? We've talked a lot about reasonable domain and range. I think it's kind of tricky, especially when we talk about money or things that you don't have to deal with a lot, but I think you know about temperature, okay? We're talking about July. And it's asking what's a reasonable domain. Domain is our X. X is our temperature above 80. Yeah.
So wouldn't it be 80 is less than X, which is less than something?
Okay. Let's you're getting real mathematical. Let's think about it first and then we'll go there. But I like your thought. Absolutely, it's going to be X is going to be between two things. I agree. Okay. So we need to talk about temperature, and it's degrees above 80. Let's go hot first. This goes up to 20. What does 20 mean in this problem? Yeah, 100 degrees. What's a reasonable upper range for temperature for July? 105, right? If you start telling me 150, we're talking about the oven, right? So 105 is a reasonable domain range, or I'm sorry, domain, right? So if we say the highest temperature we think is 105, that's reasonable. What's the coldest temperature it could be in July? Yeah, 60. I like that answer. Okay, so we think that it's reasonable that it might be between 60 and 105. Could it be hotter? Could it be colder?
Yeah.
But these are kind of reasonable answers, right? If you told me it's going to be negative 30 degrees in July, I'd be like, I don't think so. If you told me it was going to be 150, I'd be like, maybe in like 100 years it would be, but not anytime soon. Okay, so how do I illustrate that 60 and 105 here? Yeah.
60 before the X and then 105 after.
Okay, so I'm going to write this down. Don't write this down, but I want you to tell me why this is not quite right. It's not quite right.
That's supposed to be a lion.
No, I started to make it. I decided not to because I don't forget to do that. Could be equal to. I mean, I think we're okay to go either way with the equal or not. But what's wrong with this? What is our, yeah. The graph goes from 0 to 20. Why? Yeah.
Because it says degrees above 80.
Degrees above 80. So you're telling me that this could be, my upper range is 185. So we're supposed to be, X is supposed to be represented by degrees above 80. Someone tell me how to fix this.
So if you change the 60 to 80.
Nope. Because that would be 160.
So would you change the 60 to 0 and then how do you want to find?
No. Josh?
25. Less than X, which is less than 25.
I like the 25.
Yeah, that's what I was.
I don't want 0. Yeah.
Oh, because it would be above. Okay, it's talking about just degrees above.
Wait, negative.
Yep.
Negative.
Negative 20.
Negative 20. Okay. Now, I probably wouldn't fuss if you told me 0 to 25 because that's kind of where the graph is going. But to just measure 80 degrees, now, what are we talking about here? And I know I didn't read the problem. We're talking about number of beachgoers. How many beachgoers do you have when it's 60 degrees out?
A bunch.
0.
Well, it depends on if they're like vacation.
That's a really good point, right? This is a regional domain. It makes sense to me that the chart would go from 60 to 105 maybe, right? Now, they're kind of showing, though, that at 80 degrees, very few people are there, okay? If it's 60 degrees out, how many lifeguards do you want to have?
Like
0. Maybe 1, right? You want to have some protection. Okay, so that's what they're getting at there for that domain. So there's a lot to think about when you talk about in a reasonable domain. Again, there'd be a lot of range that I would accept. I would have accepted 0 to like 40 maybe, even though 40 would be a little bit high. 0 to 100? No. Okay. All right, so now this is called regression. Regression means I'm going to give you the points and you're going to just tell me the equation. And Desmos does this for you. Okay? So it's going to give you the best model, meaning it's going to consider every single point and it's going to be the closest you possibly can be to every single point. Okay? So we just draw a line and we're like, it looks like it's here. And I'm going to be when we do the first point, last point, or if I just say draw a line and give me a model, right? We could have all very different answers unless we do first, last point. But if I say just draw a model, this is going to be very precise and uses all kinds of calculations to figure out what's going on. Okay? So here is kind of the trick you need to know. And we're going to do one of these, but I just want to illustrate what's going on here. So first thing we have to do is we have to make a table. So number one, make a table. Make a table of the points we have. And then the second part is to type this weird thing in. Do you know what this symbol here is?
It's approximate.
Do you know where it is on your keyboard?
Oh, I think
Right.
Wait, I like accidentally clicked it before.
It's right here. It's right next to 1.
Oh, that's why.
Okay. Okay. It's right next to 1. Anyone know what it's called? Called a tilde.
Matilda?
Tilde. No Matilda. Tilde. So what this is going to do is Desmos is going to plot the points and then it's going to draw a line of best fit. Okay. So if we were to give this a grade, this is the grade. This R right here is our grade. Okay. What I mean by that is how close are those points? How exact is this? If this was a grade and I changed that, what grade would they have gotten to change it to a percentage? A 98. Is that a good grade?
Yeah.
It's not perfect, but it's really close. It's a good grade. That's what that means. What is this down here?
That's like you get extra points.
Say it louder. I think I heard it. That's the slope. What's this right here? The y-intercept. So from that information, I could actually write this equation. There's my equation. Okay. So that's all the things it tells you. You have to do step 1 and step 2, and it gives you all this information. It even then allows you to make an estimate on that. So let's try one of these, and we're going to do all the things. So a line of best fit means just drawing that line that we think is going to work. First, I want to create a linear model using the first and last point. Go ahead and write this on here. We do this by hand when you use the first and last point. So I'm going to give myself some space up here. What 2 things do I need to know in order to write the equation of a line? My slope and my y-intercept, am I right? So I'm just using the first and last point, because I think that that's going to give me a pretty good estimation of what's going on. So I go 9 minus 1 over 11.5. Tell me what I did wrong there. I flipped it, right? Y is on top. Sad face, Mr. McConnell. I know I should be fired. 11.5 minus 5.4. I think you should too. I'm recording this lesson, so you got evidence. Maybe I won't post this one. 6.1 over 8. Then you guys could all get the better teacher, Miss Walters.
No thank you. I'm Gucci.
So there's my slope. My B, you guys told me to find B. I'm going to plug in everything I know with an ordered pair. So I go over here and I go y equals 0.7625 x plus b. When our number is 0.7625 and stops, we don't want to round that. We want to keep all those digits. What ordered pair do you want to plug in? The first one. So I'm going to use 1 comma 5.4. And I get, so it's 5.4 equals 0.7625 times 1 plus b. A lot of you said, I didn't know what to do next when we were doing this quadratics. Yep, we got to solve this thing. Oh, I did that wrong. 5.4 minus 0.7625. I'm sorry? I know. 4.6375 is my B. So my equation, I have now all the information. Y equals 0.7625x plus 4.6375.
Really ask this like every time, but like, what would be something like that where you need to get this precise? Like, no, I'm just curious, like this precise to be able to like cutting a pot.
So on this one, I don't know what these things are, but if you're literally trying to like this next one here is talking about how many students you have and you want to be able to make estimates of what's happening. You want to be able to, do I need all these decimals if we're talking about people? No, but we'll keep them because in Southwestern, we're talking about thousands of kids, right? So you put 1,000 in there, and each of those little decimal points make a difference. Okay. Mathematics, we typically like to be super precise, and then in science or in the real world, we're like, don't tell me about 0.76 of a person, right? Count that as a person, right? So we want to be precise until the very end. Okay. Regression model. I just told you a regression model we do where? On Desmos. So when it says do a regression model, that is not by hand. That is done in Desmos. She allows them to use a calculator on certain things.
Yeah, but the hard class doesn't.
Okay, so I don't usually like having people have their Chromebooks open because some of us abuse them. I don't want to name names or point fingers, but go ahead and open this. We want to make sure we all know how to do this.
We're getting our Chromebooks out.
So first thing we need to do, and we're going to our Desmos. What was the first thing it said to do? Make a table. Okay. So we need to tell the values to the computer, to Desmos. Up here in the plus sign, I went to table. Now, what I want to point out is if you keep making tables, and I know some of you don't like to delete your stuff, and I actually kind of like that model myself, so you can go back to it. But notice how it keeps changing what they're called. Okay. And that doesn't really matter as long as you then call it the right thing later. So first thing I need to do is I just need to plug in 1, 2, it goes up to 9 for my X. And I can do it a little quicker because I have a keyboard.
We just have to press enter and it does it for us.
Oh, it does?
Yeah.
That's nice because they go up by ones. But this one, what would be the only reason I would have a different answer than you for this other column or for the final answer?
Because you have more.
Did I mess up? Oh, we don't have 1 through 9.
Yours, yeah.
1, 2, that's 4, 5, 7, 8, 9. So the only reason we would get different answers is if I typed something in different than you did. So you want to be very precise when you do this.
5.
There's no 3 or 6. Wow. Because there's no 3 or 6. Well, I don't know. Just the first question.
So it plots the points for us. And I think in the past someone said, is there a way that I can just make it draw a line? Right? And really, the first point, last point, I could do that model here too. All I got to do is just in my table put the first and last point. When it says write a linear equation, right, and gives you ordered pairs, you could do this. It does it for you. Second step is I'm going to go ahead and I need to type in what equation I wanted to find. Okay. Now, it's not y equals, it's y1. So if I type in y, you're like, how do I get that little 1 in there? If you just type a 1 in there, it understands that you're talking about that, or that it's a subscript. I don't have to do anything. And then I don't hit equals, I hit what? Tilde. So then I have to hit that tilde. So that's a special code for Desmos saying, I want you, yeah, it's fun. I want you to do something special with this. I want you to come up with an equation. Now, if I just type in x sub 1, it's going to give me an equation based on those points, right? But I want to say, I want you to make some changes. I would like to know, give me a specific slope and give me a specific y-intercept. I could have used A, I could have used C, I could use anything I want there, but I kind of like using those letters. Do you see that it makes a line that is super close to all those points? If you were to do this and calculate the average slope of all of these points, right? The average from here to here, from here to here, from here to here, and average them out and do all this calculations, this is what it would give you, okay? This was not possible when I was in 8th grade because we did not have such advanced technology. Yeah.
Why didn't we just do this in 6th grade or whatever? When we learned like to add it all up and then divide it.
This is a little bit lighting. This is where Miss Walters and this is where I even get a little uncomfortable, right? Because I could have taught you this in chapter 1 when we were learning about linear, and we could have not done any of the math that we needed to know, right? How do we find slope? We don't. We just type in the calculator. How do we find y-intercept? We don't. We just type in the calculator, right? So that's why. Now that we've made it pass, I'm showing you the trick.
Because then once you learn how to do it, and then you can figure out the easier way later.
Yeah. Okay. This is kind of like Math Papa Junior. Like it's giving you a little bit more information than that. So it asks in the question. If I go back to the question here, it's asking linear regression model. So that I'm going to say is y equals, and they gave me some values here. 0.777x when I round that plus 4.69. Did you get a different answer? This one right here, 4.69.
Oh, no, yeah.
Okay, so that tells me the equation. So over here I wrote the equation. Then it says make a prediction when x equals 20. So then I can go back to my Desmos, and based on this model of what's happening, I can go and I can figure out where x equals 20. I showed you this trick where I like to just go over here and say x equals 20. It's going to draw it for me. And then it tells me that that is 20.227.
They would always go with that little mouse and then it'd be like 20.001.
Okay, so 20.227 is the prediction. We want to use the prediction or make our prediction based on the better model. Which of these two is the better model? The Desmos. The Desmos is the perfect, as close as you're going to get. Okay, and you can see that these answers are pretty close, right? When I did it by hand, I got 0.76, 4 points. These are very close. Then it finally says, what does our R tell us about our model? So I go back and I look at my R. It actually tells me two things. It tells me I'm going to write it down. R equals 0.997. I'm just going to write the whole thing, 9972. Is that a good model? Is that a good model? If that was a test score, how did they do? It's very good, right? If I change this to a percentage, that's like a 99.7%. That's like I did one little thing and Miss McConnell was being tedious, right? You're like, just give me the points. Okay. So this is a very good model. It even tells you whether it's positive or negative. Okay. Because R is positive. So this is a very good positive model. So let's skip this one for now, just because I think we're going to get the point, and I don't want to run out of time. Same question. Here's the data. We're talking about this is talking about hurricanes. I want to show you. I have property at Indian Lake. Mm-hmm. I'm going to show you some pictures. So here's one picture. That green box is the electric box. Yeah. So this is a bathroom here. That bathroom got pulled off the house.
Wait, when was this?
When you have tornadoes last week, when you have tornadoes, the wood falls off the trees and then starts spinning around and becomes like spears. This piece of wood went through the ceiling and the roof and punctured a hole in our top of our house. Yeah.
Is it fixed yet?
It is not. No, it still looks like this. That tree fell over onto our dock and bent the dock. Got bent back.
Oh, this isn't like this is like something.
It's on an island?
It is an island.
That's cool.
That's sick.
Oh, wait. Can you go back to that video?
I just made trees.
Oh, the water.
Yeah, the water was pretty rough.
What lake is there?
Indian Lake. So
I've
this.
seen that island.
So this is your like lake house?
Yeah. So this window got busted out.
At least it was a lake house, not your house, right?
Yeah. I mean, we weren't there.
Good.
So this whole part right here, which is a bathroom on a concrete slab, got moved an inch away from the house. So when you're inside, you can see like there's a gap right here of an inch. Anyways, so hurricanes, hurricane hunters. Okay, you don't want to be that, but anyways,
I want to be a hurricane.
we're gonna make a model of the first and last value. So sometimes people get confused. The first should be the lowest, and the highest should be the highest value, right? So we're going to make a model based on the first and the last. We're going to do this by hand, okay? So I'm going to use the space down here because I already kind of used other space. But anyways, so we're going to call this my X and my Y. So I'm going to go 30.6 minus 126 divided by 1003 minus 924. So they're using the air pressure to figure out how fast the wind's going to go. So there's a correlation here that they figured out. And what they want to do is they want to use all kinds of tools to figure out what's going to happen. And it's kind of amazing when the weather can tell you, like, in 2 days, it's going to be this windy. So we get negative 95.4 divided by 97. I'm kind of using the space for this. Don't write too big there. What did I do? Did I make a mistake? 0.4, 30.6 minus 126. And then I'm going to divide these. So negative 95.4 divided by 79. And I get negative 1.208 when I round it. So that means my model is going to be y equals negative 1.208x. And then I got to figure out what my b is. So down here, I'm going to go y equals negative 1.208x plus b. When you don't know one of your letters for your equation, you just plug in one. Do you want to use the first point or the last point? Okay. Let me make something clear. Am I allowed to use any of these other points? No. I'm only looking at the first and the last point. It's like the rest of them I totally ignore. You said the first one? So it's 126 equals negative 1.208 times 924 plus b. So 120, if I times that, negative 1.208 times 924, and then I'm going to add that to 126. So that's b equals 1,242.192. It did say negative, but I ignored the fact that it was going to be added. So there's our model by hand. And those models are usually pretty good. And honestly, before Desmos, we would have been like, love it, perfect, good enough. Okay. If we're talking about taking a spaceship, you're like, can we invent Desmos? Okay. But for this, it's probably good enough. So linear regression model, I got to go back to my Desmos. If you want to, you can delete this. You can leave it and start over. Okay. But if I start over, I got to make sure that I'm using X2 and Y2. And I'm going to type these in, 924, 946. You do not have to follow. You can just follow along and not type this because you should have your other example. Again, the only reason we'd have different answers, like tomorrow when I'm working with my group and you have a different answer than I do, it's because one of us probably typed something in wrong. Because all these answers should be the same. So I type that in. I like to turn these things off. You can click on these things there, turn those things off. We want to zoom out, see my points. Okay, there's my points. You can zoom back in. Y. So this time I have to do Y what? I have to do 2. If I do Y1, it's going to give me the same equation from the first one. So I got to make sure that I use the right values. I want to know what my slope is, X2 plus a B.
Why wouldn't you just delete the other one?
You could just delete the other one. I'm just saying if you don't delete it, right? For these, I do kind of like to just delete everything and start over. So there's my equation. So it's y equals negative 1.238x plus 1274.36. If I go back to my 2 equations, you can see they're really close, right? They're pretty close to each other. So this model by hand is pretty good. Make a prediction when x is 20. That might not be a very good question. What's a better question than 20?
Like
200? 200 is even a little off. What's our range for our domain for our x? Like 900, right? So what we notice here is that the lower the air pressure, the faster the speed. So I think that's a better question. So let's change this to x equals 900. How fast would we be talking about speed? I go back to here and I say, I want to know when x equals 900. Yeah. And we can see that our speed would be about 160.4 knots. I took up all this space, but we can draw it smaller. It says, what is our R value tell? What is our R? It doesn't say what it is, but what does it tell us? So my R is negative 0.9924. The R is just right here.
Is it always positive or is it negative?
So we're going to talk about that right now. So this is negative because the relationship is negative. So this is a very good negative correlation or model. So that negative is telling us that it's negative. Up here, it was positive because it was a very good positive model. So if I were to graph this one was going up. If I were to graph this one was going down. Okay. So last set of questions over here. These are the R values. If you were asking somebody about their study and they said, wow, we found a very close correlation, you might say, what was your R value? Right? And if they say my R value was 60, you would say what?
you're capping.
You're capping, right? 60 is not good. You want to be maybe in the 80s, maybe and especially in the 90s. So here are the values. We need to match them with our different graphs. So let's start with this. Which graph, this is, I want to point out, is a positive and is perfect? Which is the one that's a positive, perfect graph? Yeah. The second one. I disagree. I think there's a better one.
The one under six.
This one right here is the best positive. So I would say that R is the one that's 100. That's one. That's 100%. Which one do you think is 90?
90 is the one above.
The one above it.
I don't.
So we took care of that one. Which one is negative 90? Bottom right. Do you see how this one is going down? And it's pretty good. So this is negative 90. Which one's negative 50? The first one. Are we following along with this?
Yeah.
What's this one going to be?
Negative 0.5.
It's 50.5. And then finally, the last one? 0. If I put this in the calculator, Desmos will make it work. They'll average it all out. It probably give you a graph like something like that, right? And you can be like, yeah, it's perfect. I see what's going on here, but it's bad. Someone said I was making a mistake.
Yeah. Negative 90.
Yeah?
Negative 9.
Oh, thank you.
Yeah. You're welcome.
Okay, we follow that? Group quiz tomorrow. If you get confused, look back on the little tilde. Look at these notes to figure out how to do that.